video, we're going to practice doing a Kruskal-Wallis test on Minitab. And so the Kruskal-Wallis test is the non-parametric version of a completely randomized design. And so I'm taking the rating data for supervisors on page 49 of your packet. So it could be a page similar to that. But so what I've done here is I've broken it down into two different columns. So Minitab needs the data to be specific, so you have all your quantitative data in one column, and then you code the treatment type for your second column. And so we're doing ratings based on the supervisor. So as you can see here, I put that supervisor 1 has a rating of 20, 19, 20, 18, 17, 16, and then we change to supervisor 2's ratings, and then all the way to 4. And so once we have it in this format, it's much easier for Minitab to actually see the data and make that Kruskal-Wallis test for us. So to actually do the test, we're going to click on Stat, and we want to scroll down to Non-Parametrics and Kruskal-Wallis. And so for this one, we'll take this out real quick. It's important to note that a response is going to be our quantitative data. It's always the quantitative data. So for this regard, our ratings are our quantitative data. And our factor is our treatment. So in this case, our treatment is our supervisor. And once we do that, we can click OK. And this is our output for our Kruskal-Wallis test. Now there's some things that you could be asked on an exam that it might be helpful to know. And so one thing I would say that you guys should know is that the rank total is equal to the mean rank times the n. Some people tend to overthink that, but mean rank times n is equal to your rank total. And so we have two p-values as well, and so what we want to do is use the p-value for the not adjusted, and so that's going to be using a p-value of 0.005. Don't use the bottom p-value. So either way though, in this case, it would be significant if we're using like an alpha level of 0.05, but just make sure you use that top p-value.